What's up, Sioux High Earth Science students? Yep, this is Mr. McLeod again. Welcome to the next amazing series of astronomy podcasts. In our next section, we will take a closer look at the relationship between three very familiar objects: the Sun, the Earth, and our Moon. We call this the Sun-Earth-Moon system. Get that down in your notes. We will also explore in some detail the phenomena you experience every day because of this relationship and what causes them. Things like tides, seasons, eclipses, day and night, moon phases, auroras. Man, I could go on forever. We're going to look at a lot of things. So again, get your notes out and something to write with, and let's roll. Okay, we have already mentioned the term rotation in an earlier podcast, but it's worth mentioning again in a bit more detail. Recall that the Earth rotates on an imaginary axis that runs through the middle of our planet. Take a look at the picture in this slide. So this solid white line right here, that line, represents what the axis of the Earth would be if it weren't tilted. I'd like you to reproduce this diagram in your notes right now, just as it is. Make sure to include all the lines in the diagram labeled properly. So go ahead and make this diagram in your notes right now. Okay, what results is that the Earth's rotation looks like this diagram now. If you didn't get the definition for rotation in your notes, make sure you get it in there before we go on. Now, astronomers believe that sometime in the early formation of the Earth, an impact of some kind knocked the Earth off its normal axis, the one we just looked at, and moved it 23.5 degrees so that its axis is now tilted and not vertical, like is shown in the diagram. So that bold line would have went someplace like this. And now this angle right here is 23.5 degrees. So the Earth is actually tilted. Make sure you get that in your notes. We've also mentioned earlier in this class that it may have been the Mars-sized object that impacted the Earth and formed the Moon that accomplished this tilt. But nobody really knows for sure, mainly because, well, nobody was there. However, the resulting tilt in the Earth becomes extremely vital to the survival of anything on our planet, including us. More about that later. Let's push on. The Earth's rotation causes some important phenomena to occur. So let's begin to get these in your notes. First is day and night. It takes the Earth about 24 hours to make a full rotation on its axis. If you need to remind yourself of that, please put that in your notes. This is why our day is considered to be 24 hours. Okay, the next important phenomena caused by the rotation of the Earth on its axis is the daily change in temperature. Write that down. So the temperature changes during the day. It's warmer. At night, it's cooler. That's an important part of the rotation of the Earth. Now, plants, animals, and even people have an internal clock that is very sensitive to light. Get that in your notes as well. Ask anyone that works midnights. No matter how dark you make the room where you sleep, it's nearly impossible to get high quality sleep during the light of day. People's bodies have an internal clock. They're used to sleeping at night. So again, this is caused by the rotation of the earth on its axis. Also recall that the earth spins at about 1,000 miles an hour. It rotates at about 1,000 miles an hour. And also recall that this speed varies depending on where you are standing. If you need to get that back in your notes or you don't have it in your notes, get that in your notes now. It's extremely important. Because it spins so fast, it creates a bulge at the equator of the earth, like shown here in the diagram, where the guy's standing there on the equator. Get that in your notes. Now, as a result of this creates differences in the diameter of the earth. So in your notes, simply write that the earth's greatest diameter is at the equator, and that its smallest diameter is at the poles. Now, it's also worth mentioning that the rotation of the earth causes a phenomenon called the Coriolis effect, something we've already gone over in this class, but that you should get in your notes because it may come up again sometime on a Friday soon. Wink, wink. Now, what I want you to remember is that the rotation of the earth causes deflections of the movement of air and water in different directions depending on which side of the equator you are on, north or south. So if you need to get that back in your notes, do it now. Next is a reminder that any moving solid, liquid, or gas is turned to the right of its intended path in the northern hemisphere and to the left of its intended path in the southern hemisphere. So if you don't have that in your notes, get it down. And you can see examples of this in the diagram on this slide. So make sure you understand the Coriolis effect. It's also worth noting that you get maximum deflection at the poles and minimum deflection at the equator, or none at all if you're right on the equator. So again, if you don't understand that, get those relationships in your notes. All right, you already know that the moon revolves around the earth. Can you remember why? Write what you think is the answer in your notes right now, and let's see if you're right. If you said that the moon is caught in the Earth's gravity well, then kudos, you're correct. Remember that a gravity well exists because the mass of an object warps space-time and creates a bulge or well in it, much like a bowling ball if you placed it on a trampoline. Now, if you need to write both of these explanations in your notes, take a second and do it now. Okay, now remember that the Earth and Moon are both spinning on their internal axis and that the Moon is revolving around the Earth at the same time. Get that in your notes. Now, what's amazing, and most likely not a coincidence, and listen to this first before you write it down, is that the moon spins on its axis at the same rate it revolves around the earth. Let me say that again. The moon spins on its axis at the same rate it revolves around the earth. Now take a second and think about this while you write it in your notes. Okay, so the moon spins on its axis at the same rate as it revolves around the earth. Now write in your notes that we call this phenomenon tidal lock. It means the Earth has the moon locked as it orbits. Now, as a result of the moon spinning at the same rate it's revolving, we only see one side of the moon at a time. Write that down. So as a result of the moon spinning at the same rate it's revolving, we can only see one side of the moon at a time. We never see the back side, referred to as the dark side of the moon. A nod to a classic rock band, Pink Floyd, who had a famous album and a song with that same name. So write down that the side of the moon that we don't see is referred to as the dark side of the moon. Now let's see how that works in this simulation. If we take a look at this simulation, we see now that the moon is spinning on its axis and so is the Earth. Now, what we see now is only one side of the moon facing the Earth because it spins on its axis at the same rate it's revolving around the Earth. So if you look at a full rotation here, you see that we never see the side of the moon we're looking at right now in this simulation. We're looking at the dark side of the moon. But if we were on Earth, we'd be standing there looking on the side of the moon that we see all the time. And remember now, it's because the moon spins at the same rate it's revolving around the Earth. So no matter where you are on the Earth, you can only see one side of the moon. Okay, the next phenomena caused by the rotation of the Earth are the tides. Write in your notes that tides are the rhythmic rise and fall of the water level of the oceans as the Earth rotates on its axis. So write in your note that the tides are the rhythmic rise and fall of the water level of the oceans as the Earth rotates on its axis. So write that in your notes right now. Then write that the tides are the result of the gravitational pull of the moon and sun on the Earth's surface and water. That the tides are the result of the gravitational pull of the moon and sun on the Earth's surface and water. So get that in your notes right now as well. Okay, take a look at the diagrams above, and let's try and make some sense of the tides and what causes them. First, the word revolution describes an object moving in a circular shaped path around a central point or object due to gravity, like the Earth does around the sun, like the moon does around the Earth. If you don't have a definition for revolution, get that in your notes. Now, as the moon revolves around the Earth, it pulls the water on the nearest side of the Earth towards it or outward into a bulge like is shown here in the diagram. You see that here's the moon, and what happens now is it pulls the water of the oceans toward it, like this arrow is looking at right here. And that the sun does the exact same thing. So it pulls on the water on the side of the Earth facing it. Get that in your notes. Now the moon's gravity also pulls on the solid Earth as well. But since water is less dense than the earth, it has a much greater effect on the water than it does the earth. Write that down. So as the moon moves around the earth, it always pulls on the side of the earth facing it. Now remember, the earth is spinning at the same time. So as the moon is revolving around the earth is spinning on its axis. So the tides will not occur at the same time on the same location on the earth. However, they do occur at regular intervals on the surface of the earth, about every 4 hours. So they can be predicted because of these rotations and revolutions. Now here's the strange part. Write in your notes that a similar bulge occurs on the opposite side of the earth. So as the moon pulls in this direction right here, it also pulls the water here and also pulls on the earth here. So there's not only tides on this side, but there's tides on this side as well. Get that in your notes. Same thing with the sun. The sun does the same thing. It pulls this way on the water on this side and also pulls this way on the water on the other side, creating tides. All right, now let's take a look at a simulation of how this works. Remember that the sun and the moon both have an effect on the water on the surface of the earth. Now let me ask you a question. When would the highest and lowest tides occur? Would it be when the moon and sun are lined up with the earth, or when they are at right angles to the earth? Think about that and write what you think in your notes right now. If you said when they are lined up, you're correct. Let's take a look at a simulation. So here we are now. We have the sun right here. We have the earth right here. And we have our moon right here. So I'm going to let this run. And what you want to watch now is this blue ring around the earth represents water, the ocean water. By the way, if you were wondering if the moon and sun have effect on lakes, they do. But because the lakes are so much smaller than the ocean, the effect that it has on the lakes is very minimal. So they do have tides, but we're talking about 4 or 5 centimeters worth of water movement. And that's really not something we would ever see. Whereas ocean tides are extremely easy to see. If you've ever visited the ocean and stayed for any length of time, you can see what a dramatic effect it has on the oceans. I'm going to tell you, ask me and I'll tell you a funny story about my visit to Maine with my wife and a question she asked while we were there. All right, so let's run this simulation. So now here's the moon now, and as it approaches the sun, in other words, as it gets closer to being lined up to the sun, look at the effect it has on the water. See how much more of a bulge there is here with the water than when the moon was here? So the greatest bulge would be when they're completely lined up. Now in your notes, I'd like you to write this little diagram simulation and call it spring tides. So spring tides, so write this little diagram here and write the water, the big water bulge there, and the sun and the moon lined up. This is called spring tides, not because it occurs in the spring. They call it that because of the large bulge that it creates in the water. These are called spring tides. When the sun, the earth, and the moon are in a straight line. And also write that that's when the tides are at their highest and lowest. Spring tides. So get that down in your notes. Now let's keep it running. So now we're moving away from that alignment. Now watch what happens to the water here. As we get now to this side, you're going to see now a dramatic change in the way that this water is pulled. It's much smaller. Now we call this, let me get all the way up there. Now the moon is at right angles. Well, here's what we mean by right angles. Now we mean that the moon is at right angles to the earth. Now, when the moon is at right angles to the sun and the earth, these are called the neap tides. N-E-A-P. It's thought that the word neap is Greek for small. So when the moon is at right angles to the earth and sun, this is called the neap tides. N-E-A-P. So write that in your notes. Now also write that this is when the tides are at their lowest. In terms, the least effect is what I really mean. This is when the moon has the least effect on the water. So there wouldn't be as high a high tide or as low a low tide. So make sure you get that distinction in your notes right now. So let's continue to make this run, and let's see what happens now as a result of it moving. So here we go now. I'm going to stop this. And when the moon gets right here lined up, what would you expect about this bulge? Think to yourself what you would expect, and let's see if you're right. So look at the bulge. Bigger and bigger, and now they're lined up. And now that bulge is as big as it's going to be. Now, question for you. Is this a spring tide or is it a neap tide? If you said that it's a spring tide, you're correct. Remember now, in this situation, we have the moon, the earth, and the sun completely lined up. Bad lines, but you see what I mean. So that is called a spring tide. A spring tide. Now let's continue and run it here. And now when we get the moon at right angles to the sun and the earth, we're now getting to which kind of tide? Not the tide that washes your clothes, but this now would be a neap tide. So when they're at right angles now, again, bad line, this is called a neap tide. So make sure you understand those distinctions and can explain them and recognize them in a diagram. Okay, we're done with part 1 of the Earth, Moon, Sun System podcast. Go grab those questions from Moodle and then move on to part 2 when we're done. See you later.